Hi there, my name's Simone Bennett. I'm a principal consultant at Arcana. And before that, I worked for Microsoft and I talked about the well architected framework all the time. So I'm here to talk about building solutions with a well architected framework. I'm just recovering from COVID, so I hope that you'll stick with me even if I start to get a bit croaky or confused as we go through. I'm really looking forward to hearing your feedback and feel free to reach out to me if you think there's anything I missed. I love hearing if this was useful and if you adopted any of the tools that I suggested. All right, without further ado, let's get going. So the cloud adoption framework and the well-architected framework go together. So what we're going to do at first is talk about the key principles of the well-architected framework. We'll cover off the 5 pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. And we'll talk about how does a well-architected framework fit in with the cloud adoption framework, and how do we make them part of our dev process? So how do we shift what was traditionally seen as something that was done after a workload was deployed left, so it becomes part of our process every day and we build it in. And just before we get further in, all the clouds seem to have a cloud adoption and a well-architected framework, but I just want to make sure everybody's on the same page when I'm talking about them because they can be a little bit confusing sometimes. So the cloud adoption framework talks about our end-to-end cloud journey. So how do we adopt cloud? How do we plan for it? How do we build a landing zone? How do we manage and govern it long term? And then the well-architected framework, I guess, falls in that govern and manage portion of cloud adoption framework, where it's focusing on individual workloads and making sure those individual workloads are well architected. So you've got cloud adoption, which is the whole journey, and well architected, which is individual workloads. And in the cloud adoption framework, which manages your end-to-end cloud journey with opinionated cloud adoption guidance, you have landing zones. And a lot of people I show this graphic to think, oh, that's just big. I don't need anything that big. That's too complicated. And a myriad of other reasons why they think they shouldn't adopt it. But I'm trying to convince you otherwise in one slide. So when you spin up an environment, even if it's just for a demo, if you're like me, you'd be like, okay, cool. I need to deploy this environment. And then you're like, oh, I need a network. Oh, I need subnets. Oh, I need DNS. I need private endpoints. I need key vault, blah, blah, blah. And you kind of end up building this anyway, just in a less structured way. And then once you start using it, you hit some limitation and then you need to rebuild it and then you need to migrate it or retrofit it. And the cloud adoption framework landing zones is an opinionated way to future-proof that and sort of skip that process and just make sure you have a workload based template there. Everything's in place. You can just put things into it. It will scale. It's well architected, and you shouldn't have to go back and remediate it later. So it's not well architected, but it's kind of a big part of being well architected as well. Anyway, on with the show. Well architected. So well architected is broken up into 5 pillars: cost optimization, operational excellence, performance efficiency, reliability, and security. Obviously, cost optimization, well, how do we design cost optimized workloads, right? How do we have budgets and save costs? Operational excellence, we want to design reliable, predictable, automated deployments with monitoring, with performance management, and with extensive automation and testing baked into our applications wherever it can. And we want to think about what do our pipelines look like for deploying applications? If we detect errors in production using our monitoring tools, can we just roll back? Is that problem-free? Then we have performance efficiency. What is the ability of our system to adapt to changes in load? And how do you know if that's happening? Can it scale? Things like that. Resiliency and reliability, I guess, we all know what that is our system able to recover from failures and continue to function? And how are we designing our environments and our applications to be highly available? And is there an active disaster recovery plan? Does your team know what to do if there's an outage? Do you know what the impact is? Things like that. And security. I mean, security is at the front of everyone's mind. We don't want to be in the news. We don't want to be the people with the breach. So we want to build security by design, and we want to make sure we can provide confidentiality, integrity, and protect against those deliberate attacks, especially the ones, targeting important and confidential data. And when we look at the well-architected framework, the 5 pillars here have originated from common challenges that Microsoft customers have faced in the past using their cloud technologies. So if you think about how many customers that is, that's a lot of data that could be collected to make sure this is good advice. And even today, the customers I've worked with at Microsoft and at Arcana and other companies, these issues are not unique. Every company all the time faces these issues. So if you're facing them, you're not alone. And don't worry, there's a path forward. So we can get there together. But essentially, the well-architected framework directly addresses these issues in a structured way by breaking them down into pillars and then providing best practices guidance for each pillar that's easy to prioritize and implement. And then these are examples of some of the best practices you might find in your recommendations when you do your well-architected review. Things like designing for scale or using DevOps or using Azure hybrid benefit. So they're just some examples of what you might see when you get your recommendations. Okay, cool. So hopefully you're convinced. Hopefully you think, okay, yeah, I'm down. I don't mind well architected. You're at the talk, so you're already slightly interested. So hopefully I didn't have to convince you too hard. But you know, it seems onerous. Maybe that's why you're not doing it already. Maybe that's why it's not done very well already, because it seems quite large and hard to implement. And that's good for me because I can help you improve. No, that's not good. I don't know why I said that. It's just, it is what it is. You're not alone. But I did really read a really good article the other day about Microsoft and how in the software development team for Skype for Web, they sort of changed the way Microsoft thought about this kind of stuff. They used to have teams to build stuff, and they used to have teams to test it, and then they have teams to release it, whatever. And then they decided to eliminate that us versus them dynamic, and they emphasized a unified engineering approach. And what they found was when they did that, it really resulted in improved quality, improved agility, and improved engineer satisfaction. So it really started a movement at Microsoft of integrating that testing and well-architected practice into the development process for better collaboration and better adaptability. And the proof's really in the pudding because they went from having monthly releases where they build a thing, test it, pass it back, fix a thing, test it, pass it back and forth until it was ready to release. And then once they did this and they had that one team, it went from being, you know, irregular releases to daily releases with a really good quality product. And I think we can also bring back Skype. It was a really good product and I miss it. No Teams, no offense to Teams, it's fine. Teams is great. So what do we call that? When we build that stuff, you know, into our dev process, when we take it as close as possible to the people building and designing our workloads, and when we try to really resist tacking it on the end and then having to rework things, we call that shifting left. And when I think about shifting left, I'm asking myself, how do I build the WAF pillars into my dev process? And how do I reduce cognitive load and decision fatigue for my teams around making sure workloads are well architected? And can we make adhering well architected principles easier by changing and tweaking our code and design in the early stages of our processes, not after, when teams might resent those changes or find them to be blockers, or just, you know, really hate them because it's rework? Let's put it at the start so then there's no rework required. Also, I used Microsoft Designer to generate all these images. So some of them are a bit quirky, and I thought, you know, they're like little Easter eggs for anyone who's paying attention. So where do we start? Okay, you're sold, you're in. My suggestion would be to build a baseline with the go live assessment or the well architected review. And when you do that, I would say do it with an open mind, because you're probably going to get a ton of recommendations, but it's a great baseline. And you can measure it and you can improve on it and you can show your improvement because it's measurable. So don't be terrified if you have a lot of recommendations there or low scores in some of the pillars. And it's also really important to understand you don't need to improve these things right now. They don't need to be all sorted straight away, but you do need to have awareness of them. You do need to know that you can be better in some places, and you need to have a process and make sure you're always improving and measuring that improvement. And I guess it's really good to make sure the business can make informed decisions about the risks of things they're not prioritizing and things that are staying in the backlog. So having that baseline and having a security score, a well-architected score, is a really good way to justify those remediation activities that are non-feature focused and show that they're still improving your product. So if you have a secure score of 40, your secure score should be 70 or more. You can show we did a bunch of work. It wasn't new features, but our secure score is 70 now. So we're a lot more safe and we can give our customers a better experience. It's I like things that are measurable. Cool. So where do you do that? So go to aka.ms assessments, or the proper link is on the page there if you would like to check it out. And then you want to look for the go live well architecture review for workloads that aren't live yet. So if you're getting ready to launch something, or you're sort of mid-design deciding if you're ready to launch, the go live review is for you. If you have a workload that's in place already and has been running for a while, the well architecture review is for you. You could do both and interchangeably, but they're probably best suited to those scenarios. You fill out the questionnaire with your team, and then it will give you a CSV full of recommendations that you can prioritize and put into your backlog. And if you're in the platform team, or you build the platform as well as the workloads, and you want to check that that's all good as well, the Azure Learning Zone review checklists are an invaluable resource. Or you can do the Azure Learning Zone review in the well architected assessments page as well. But it's not necessarily well architected, but it is, if you know what I mean. So I thought it's really good to make sure people know it exists. Okay, we have a baseline. What now? So next we want to focus on how to reduce that cognitive load and decision fatigue on our teams. We want to change or tweak our code in the early stages. We want to find issues before we're finished building and have continuous feedback. And to do that and figure out the best way to attack that, let's look at each pillar in the well architected framework and how we might shift each one of those left. Whew. We're halfway through, so I hope you're sticking with me here. So we've got balancing the book's cost optimization, and it's one of the first ones I think of because it's usually really invisible to our teams. There's great tools in the portal like cost management, Azure Budgets, Azure Advisor, but a lot of the times the dev teams don't see them or they don't know they're there. And so we need to think, how can we make that stuff visible as we develop? How do we push that info to our teams instead of needing someone to go and find it? And how do we give our teams immediate feedback and visibility so they can sort of course correct as they're going and developing and making design decisions? Well, my friends, I have a really cool tool that I like in my arsenal called InfoCost. It used to be a really simple tool that you just put in a pipeline or into a VS Code extension, and it would surface the costs of your deployment in the pipeline or in the code blocks within VS Code. And it still does that, but it's I went to check the other day and it's built right out into a really thorough SaaS app now with like policy and deployment gates and a bunch of reporting. For me, I mostly just want to see it in my pipeline, right? I just want a really basic functionality there. So you can go and check it out, have a look at the VS Code extension, which is really cool, and have a look at the pipeline CLI. So you can just start to have a look. And if you find it valuable, then you could build it into your GitHub organization and have everybody using it by default. If you're not using Terraform, but you really like the idea of it, there's a similar tool called the Azure Cost Estimator, and that's for ARM. I haven't used that one because I'm Team Terraform, but whatever you use, tools like this will really help surface that cost to you right at the start. You choose a SKU, you don't realize it's going to be $6 million a month. Before you click go, you can see it right there and you can think, oh, okay, maybe I need to change my design to use a less expensive SKU. Great, so a really important part of cost management is tagging. And they provide the visibility needed for businesses to manage and allocate costs across different groups. There's been some debate in our team about policy being set to deny if not exists versus audit. And I guess that's really something that you will need to think about in your team. But I would usually suggest forcing tag compliance with Azure policy. There's 2,000 plus resources in Azure, and only 625 of them are taggable. So what I normally do is have the tags forced on the resource group and then use Azure policy to replicate those tags down using tag inheritance to everything within the resource group. And that means everything's tagged, even the ones that aren't taggable in the traditional sense. So it's a really good way to get around that. If you have your policy in audit mode, to say these don't have tags, but we're still going to allow you to deploy, I would suggest setting up alerting and monitoring so that the teams at least know they need to tag that stuff before deploying, and then having it on deny if not exist in prod. There's been a big debate, like they'd rather get blocked in dev, so they know they'll go fine in prod, versus some people who want velocity in dev and then just knowing that they need to remediate that stuff for prod. So it's really up to your team. But either way, I would use Azure policy to enforce tagging so that your cost optimization and your reporting can be as good as it can be. Other things that aren't super easy to automate into your pipeline, but still can give you really good feedback in near real time, as cost management and budget alerts. So again, you can use Azure policy. You can say if this workload doesn't have a budget and doesn't have alerts set, create them. You can set the budget amount and all the other alerting stuff in the policy. And then you could have those policy alerts sent to the people who are building the workload. Don't send them to accounting or the platform team or whatever. Send them to the team who's building this. So say when they get to 50% of the forecasted budget you've set, they get an alert and they can say, oh, okay, we had no idea that was costing that much money. And they can go and take a look at it. They might not realize they've left a database running, or, I've had, people leave Synapse running all weekend and they have no idea because they don't get the alert. So they can't remediate it before it costs a ton of cash. Speaking of tons of cash, you can save tons of cash by reserving instances. And it's one of the first things usually you talk about when you do cost optimization. It is not part of your pipelines. It is not built in to WAF, but I just thought I should deviate a little and make sure reserved instances are on the front of people's minds. A lot of people I know don't buy them because they think it's just virtual machines, or they think you're locked in. But you can trade reserved instances, you can change them, and you can reserve all of these things. So it's not just virtual machines. There's a ton of things in Azure that you can reserve, and you can save, around 40% on some of those workloads by reserving capacity. Things like backups, I've seen really good savings, and databases. So completely not automated, not entirely well architected, review related, but it is cost optimization related. So I wanted to make sure that I called that out. And now we will go back to our scheduled programming. The FinOps workbook. Again, it's not automated in our pipelines, but you can configure it. You can create alerts. You can automate those reporting, and it gives you all the FinOps recommendations for your environment. So if you want to be cost optimized and you want to really get into it, FinOps workbook is another great resource for you. Okie doke. I have no idea how I'm going for time, so maybe I should hustle. Okay, so our next pillar is building a solid foundation around operational excellence, and that is holistic observability and automated systems. It covered things like automated testing, deployment gates, infrastructure as code, DevOps, Jenkins, GitHub, etc., all those things. So essentially, we want to make sure we have consistent and repeatable infrastructure deployments, and your workload would be, I guess, written in code. So you might use tools like HashiCorp, Terraform, Pulumi, or Bicep, or you might use something else. Whatever it is, it doesn't matter. If it's written in code and it's repeatable and it's consistent, then it's good. And if you aren't sure what one to use, I usually opt for a cloud agnostic tool, just so that if you have third-party things like firewalls, or you have to do one thing in another cloud, you have the same code base. But again, it doesn't really matter so long as it's repeatable and it's consistent. You're onto a winner. And you say, oh, that's Simone. We didn't know about this, and some of our stuff's been ClickOps, and so now we have some stuff as code and some stuff as ClickOps, and it's really hard to, build well architected into our pipelines, and it's hard to do all this stuff. That's okay. There's tools to help with that. So If you're using Terraform, AZTF export will go and import that stuff into Terraform for you en masse. You can use the import commands in Terraform also, but this definitely speeds you up. It used to be called AZ Terrify, which I really liked because I could make jokes about it being terrifying. But now they've ruined it and given it a really sensible name, so that's fine. And then there's AZOps, which does the same thing, but for ARM templates, which you can convert to Bicep really easily in VS Code. So whatever you're using, if you've got a ClickOps environment or you're picking up brownfield, consider porting that stuff into code with one of these tools so that you can manage it going forward. Okay, so in your pipeline, you've got your infrastructure as code, and you want to make sure it's well architected. This tool is amazing. PS rule is written by a guy in Brisbane called Bernie White, and it has the entire well architected framework, and it builds it into tests and checks into your pipeline, gives you suggestions on how to fix stuff, links to them. It's a wonderful tool. It's aimed at ARM/Bicep, but you can use it with Terraform and other pipelines as well. So I would suggest if you want to automate as much as possible of what we're talking about today, go check out PS Rule and give Bernie your feedback, or it's open source, so you can contribute if there's something you don't like. So I guess we have automation covered to some degree, right? We're doing infrastructure as code, we're using pipelines, where, whether you're using GitHub or Azure DevOps or Bitbucket or whatever you're using for your automation. They're the only two I can think of, Jenkins. But operational excellence also means your workload should be holistically observable. So monitoring is a big topic, I know. But this could be a good place to start. If you've got a platform in place and you want to monitor the platform and you don't know how to monitor it or your apps, Azure Monitor Baseline Alerts is a tool from Microsoft. It's a repo. And it has all of this monitoring that's built as Azure policy, all the PG teams, which is the product group teams that Microsoft contribute, and validate them. So they make sure that these things can monitor their products well, and they have the baseline things they think you should monitor. So if you don't know where to start and you don't know how to have observability in your workloads, the baseline alerts is there. It's policy, so it can just auto apply as you build things. You sort of set it and forget it. Excellent. And then if you are looking at your application and you're building an application or a workload and other people are going to have to monitor it, you would need something like OpenTelemetry. And Jake and my team, who loves OpenTelemetry, convinced me that it's a great idea because it allows you to instrument your software as you're building it. So it's easier to monitor and action things later. You can do things like set it up so it can monitor database queries and tell you which ones are slow, or make sure the team thinks about what needs to be monitored as they're building it and build that in. And his example was .NET. If you use .NET applications, you can pop them on Azure, you can just turn on App Insights and everything just works. And that's because the .NET team really thought about what instrumentation is required for monitoring, and they've built that into their application early. And then you as a user can just use it. So I guess it depends if you're using an application or you're building one, but there's a couple of tools there to consider when you're doing that. So I should say, as a bit of a summary before we move on to the next pillar, to be operationally excellent, we need to automate and monitor things that we build. We need to think of ways to build that into our processes, and we need to change or tweak that code early. So for this pillar, we need to find issues before we're finished building, and we need that continuous feedback as we go. Same as all the pillars. And I promise we are nearly done. So if you're doing the well-architected review, just keep listening in the background. There'll be a quiz at the end that you need to pass before you can leave. Kidding. Okay, so I switched these next two together because in my mind, they overlap a little bit. They're about scaling your system to handle load and identifying bottlenecks and adjusting to changes in demands placed on the workload. And we want to test those changes before deploying into production and being able to respond efficiently to failure. So we've got bracing the chaos with reliability and accelerating your journey with performance efficiency. And you can see that when you look at the two things in the pillar, they kind of line up pretty well. So keeping with the theme of like, well, how do I do that? How do I care about that stuff at the beginning? How do I build that stuff into my process? How do I give that feedback about it being well architected to my teams while they're writing the code. I would say linters are an excellent start, right? So PS rule we talked about, TerraTag, TF-lint or CF-lint, they're excellent. You can't push your code when it's got problems with it. Security or formatting or other well architected pillars are covered. So they're really great. There's things like Nomad or Playwright or Chaos Studio and load testing. They're services that maybe aren't built into your exact pipeline every day, but they can still be built into your process for deployment and testing and user acceptance testing. Chaos Studio especially is cool because it uses chaos engineering to help, create random failures so you can test your resilience. And I think, when stuff really goes wrong, it's always something we didn't think of. So Chaos Studio could be good there. And load testing is really good for just putting massive amounts of load on your application to test how it will go when it's live. They're the ones I really like, but if you have other ideas, please reach out and let me know so I can add them in for next time I give this talk. And then when it comes to testing and building tests into our environment, everybody seems to know that it's a really good thing to do, but lots of people aren't actually sure how to do it. And so I think Copilot would be really helpful here. I just asked Copilot, look at my Terraform repo and can you help me build some tests for this? And it wrote some blocks of code to build TF-lint into my pipeline, as well as a bunch of tests that you could just copy and paste into your pipeline, which is really cool. So if we want to make sure our workloads are reliable and performant before we finish building them, we need to build those tests into our process. So take advantage of the tools that are out there to make that easier for you, even if they're simple tests as a start, and then you get more complex as you get more familiar. You need to apply load so you can change and tweak your code in the early stages of the design, and you need to take advantage of the tools that can automate that, like Azure load test. And then we need to find single points of failure, and we need to find scaling limitations before we finish building. So as we discussed earlier, we need to monitor, and act on those alerts as we build. Cool. We are getting so close to the end and I'm running out of breath. I'm not used to having no time for questions. Okay, so fortifying your castle security. It's a big one, okay? Like it is, if you're thinking about security, it's just an endless, there's so many things that could go wrong. There's so many people trying to attack you every day. But really the main thing we need to do is have the ability to proactively secure our code right when we're creating it. So instead of it being an afterthought, it needs to be built into our process every single day. People need to be thinking about security at the front of their mind when they're working all the time. And a really good way to do that is to really have it in your face when you're pushing code, have it in your face when you're writing code, have it in your face when you're testing, all those things. Definitely make sure that remediating those vulnerabilities and finding them is not something that happens after the fact and then it has to get pushed back through as a rework. Make sure security is something we think positively about and that we build into our process just as part of our culture. And so we need to build it in, but we also need to monitor for new vulnerabilities every day. Maybe you built something that had log4j and then suddenly it's not secure when it used to be. And so that can be a lot to take on, right? There's building it in and keeping it secure as we go. And I can hear you going, oh, that seems like just a lot, right? Like I'm just doing my best. But there's some amazing tools out there now that focus on security and make that a lot easier for you and your teams. Almost every platform you look at has some sort of security built in. Like I mentioned earlier, Infocast does, HashiCorp has Vault and Sentinel. One of my favorites is GitHub Advanced Security. It just kind of automates a lot of this for you. So it just takes away the pain. Over the past year, they've released more than 70 features to improve it, which is just phenomenal amount of development there. They include software testing, supply chain security. I really like the Dependabot scans for vulnerabilities because it just creates the PR for you. So the juniors in my team just accept the PRs and off they keep going. And if I can use it, and if the juniors in the team can use it, I feel like anyone can use it, review the PRs and keep on going. You don't need to go and remediate that stuff and Google it and figure it out. I also really like the new version that has the ability to group those multiple version updates into a single pull request. So there's not as many pull requests to review. I like that it does secret scanning and then you can customize those secret scans, and also that it's free for public repositories, which is excellent. There's some preview features that I put on the slide there just for people who are interested. But one I didn't mention on the slide but should talk about is probably that you can also use it for Azure DevOps. So that's double excellent news if you're in the Azure DevOps camp, but you really want to use GitHub Advanced Security. You can. And if you're already using GitHub Advanced Security, or that's, you know, a little ways away for you, again, look to those linters. So things like PS rule, checkgov, tflint, or cflint, they're going to be great just as a starting point, and you can just implement them, you know, right now. Not now. You can implement them in 10 minutes when this talk is finished, but ASAP, you can just pop them in. And then, of course, those other surfaces that we talked about before will also help with your security in your code. Yeah, so revisiting this slide. So many of these tools help. They're making sure you can't even commit code that's vulnerable, and they're really good for that culture of building security at every stage of your process. Team, we made it. In summary, we have the 5 WAF pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. We talked about how does the well-architected framework fit in with the cloud adoption framework? How do we set a baseline so we know how to improve? How do we build those pillars into our dev process? Or, you know, if you want to use a buzzword, how do we shift left? How do we reduce cognitive load and decision fatigue around making sure those workloads are well architected for us and for our teams? And can we make adhering to the WAF principles easier by changing and tweaking our code and design in the really early stages of our process, by providing feedback as we go through that coding and design phase, and not providing that feedback after, when the teams might resent the changes because it's rework and it's a blocker? And can we baseline our well-architected status and look to see where we can improve and manage and report on that improvement using the measurable outcomes for the well-architected scores and secure scores and things like that? Kind of fumbled over that one, sorry, fam. But anyway, we're done. So this is me. I would love your feedback. I would love to know if there's any tools I missed or stuff you do that you think works really well and that I should tell the world about next time I get the opportunity. Thanks so much for your time and the opportunity to speak at this event. It's been wonderful, and I hope you enjoyed it. Thanks.